If you're brand new to Java, this video is your on-ramp. We're going to walk through 5 core building blocks in the order they naturally build on each other: variables and types, control flow, methods, arrays and lists, and finally classes and objects. By the end, you'll be able to read almost any beginner Java program and understand exactly what's happening, line by line. Let's get started. We start with the raw materials of any Java program: variables, the built-in primitive types, and the operators you use to work with them. Declaring a variable in Java means giving it a type up front. You can't just say x equals 5 like in Python. Here we declare an int and set it immediately, declare a string and assign it later, and mark a constant with final, which means once it's set, it can never change. Java has 8 primitive types, and these 5 cover almost everything you'll use day to day: int for whole numbers, long for really big whole numbers, double for decimals, char for a single character, and boolean for true or false. Notice you can use underscores in big number literals just to make them easier to read. Everything that isn't a primitive is a reference type: strings, arrays, and every class you write. This matters in practice because collections like list only hold objects, not raw primitives. So when you add an int to a list of integer, Java automatically boxes it into an integer object, and unboxes it back to an int when you read it out. Widening a type, like an int into a long, happens automatically because you can't lose information going up. Narrowing, like a double into an int, needs an explicit cast, and you can lose data. Casting a double to an int truncates the decimal part instead of rounding it. Watch out for integer division. 10 divided by 3 as ints gives you 3, not 3.33, because the decimal part just gets thrown away. If you want a real decimal result, cast one operand to double first. The percent sign gives you the remainder, and it's one of the most useful operators for things like checking even and odd. With variables and types in hand, the next question is how your program makes decisions with them. That's where control flow comes in. Now that you can store values, let's make decisions and repeat work: if-else branching, switch, and the 3 loop types Java gives you. The classic if-else if chain checks conditions top to bottom and runs the first branch that matches. Age 20 is not under 13, and it's not under 20 either, so it falls all the way through to the final else and prints adult. Only one branch ever runs. A classic switch statement compares one variable against several discrete values. This is the one place in Java where you have to be careful. If you forget the break keyword, execution falls through into the next case instead of stopping, which is a classic beginner bug. Each case here breaks properly, so only Wednesday prints. Modern Java lets you write switch as an expression instead of a statement, using arrow syntax. There's no fall-through to worry about. You can group multiple cases on one line like 4 and 5 here, and the whole thing directly produces a value you can assign. Much safer and more concise. A while loop checks its condition before every run, so it might execute 0 times. A do while checks after the body runs, guaranteeing at least one execution. Notice n is 0 and the condition n less than 0 is already false, but the loop body still fires once before it quits. The classic for loop is perfect when you know how many times to repeat, or you need the index itself. The enhanced for each loop is simpler when you just want every element of an array or collection without tracking an index. And inside any loop, break exits it completely, while continued just skips to the next iteration. Once you can branch and loop, the natural next step is packaging that logic into reusable methods, which is exactly where we're headed next. Methods let you name a piece of logic once and reuse it everywhere. Let's look at how to define them, overload them, and where their variables actually live. Every method signature has an access modifier, an optional static keyword, a return type, a name, and its parameters. This add method takes 2 ints and returns their sum. Notice it's declared static, meaning it belongs to the class itself, so main can call it directly without creating any object first. Overloading means multiple methods can share the same name as long as their parameter lists differ, in count or in type. Java figures out which multiply to call based on what you pass in. 2 ints picks the int version, 2 decimals picks the double version, and 3 arguments picks the 3-parameter version. This is the key distinction. A static method belongs to the class and can never touch an instance's fields, while an instance method needs an actual object to call and can read and change that object's own data. Here, increment and getCount need a counter instance, but describe is called straight on the class name. Variables declared inside a method or a block only exist within that block. Inner is created inside the if statement's braces, so it's visible while we're inside them, but the moment we step back out to the method's outer level, inner simply doesn't exist anymore. Methods are great for logic, but real programs need to work with lots of data at once. That's where arrays and lists come in. Now let's scale up from single values to collections of them, starting with the fixed-size array and then the resizable array list. An array is a fixed-size block of elements of the same type. You can initialize it with values right away, or declare its size up front and fill in slots later. And remember, length is a field you access without parentheses, not a method call like it is on a string. Java also supports two-dimensional arrays, essentially an array of arrays useful for grids or tables. You index into them with row and then column. And nesting a for each loop inside another lets you walk every row and every value inside it cleanly. Unlike an array list can grow and shrink as you add and remove elements, perfect when you don't know the size ahead of time. Notice remove is overloaded. Passing a string removes by value, but passing an int removes by index, which trips people up the first time they see it. Because a list only holds objects, an array list of integer autoboxes every int you add, and auto-unboxes it back to a primitive int on each pass through the for each loop, so summing scores reads exactly like it would with a plain array. You now know how to hold many values at once. The last piece is bundling data and behavior together into your own custom types classes. Everything you've learned so far, variables, control flow, methods, arrays, comes together here, in the tool Java uses to model real things, classes, and the objects you build from them. A class is a blueprint, and each object you create with new is a concrete instance of it. The constructor runs exactly once, when the object is built, and this .name disambiguates the field from the parameter that happens to share its name. Alice and Bob are two separate person objects, each with its own name and age. Constructors can be overloaded too. Here, a square is really just a rectangle with equal sides, so its one-argument constructor calls the two-argument constructor with this, passing the same value twice, instead of repeating the assignment logic. That's a small but real example of not repeating yourself. This is encapsulation. Balance is private, so nothing outside the class can reach in and set it directly. Instead, every change goes through deposit or withdraw, which can enforce rules: no negative deposits, no withdrawing more than you have. That validation is exactly what you lose the moment you make a field public. The method's area and circumference live on the class once, but each circle object keeps its own radius. Calling area on C1 and C2 gives completely different results, because it's operating on that specific object's data. This is the whole point of bundling state and behavior together in a class. That's the full arc: values, decisions, reusable logic, collections of data, and now the objects that tie it all together. Let's wrap up. That's Java's foundation in 5 stops: variables and types, control flow, methods, arrays and lists, and classes and objects. Each one builds directly on the last, so if any part felt shaky, that's exactly the lesson to go back and reread. Every lesson we covered today is linked below in order, with full explanations and the exercises to practice on your own. Thanks for learning with us.